Alright, so for this problem we have 1 to the power of x equals 2. So this seems impossible since 1 to the power of anything is just 1. So pause video here, think about how we might solve this. Alright, so onwards towards the solution. So we can take the log base 1 of both sides to isolate for x. So we have log base 1 of 1 to the power of x equals log base 1 of 2. And we have the same logarithm and base on the left-hand side, so this cancels. So we have x equals log base 1 of 2. So we use change base formula here, convert this to natural logarithm. And here we run into an issue. Since ln1 is just 0, since e to the power of 0 is 1, so we have ln2 over 0. So there are no real solutions. So now we must convert 1 into its polar form. So over here we can draw the complex plane. So the x-axis is the real component and the y is the imaginary. So 1 has no imaginary component, so it is just on the real axis. So we have 1 here. So we're converting 1 to the form re to the power of I times theta, where r is the distance from the origin and theta is the angle. So r is just the absolute value of 1, which is just 1. And theta is 0 or 0 degrees. And we can also have any number of full rotations. So 2 pi times k, where k is an integer. So now we see 1 is equal to e to the power of I times 0 plus 2 pi k. So now we can come back here and we have ln2 over ln of e to the power of I times 0 plus 2 pi k. So we see the ln and the e cancel here. So we're just going to be left with ln2 over, so I times 0 plus 2 pi k, that's just I times 2 pi k. So now we can multiply by negative I in the numerator and denominator. So what this does for us is I times I is negative 1. So adding in the extra negative will allow us to cancel the I in the denominator and move it to the numerator. So this is negative I times ln2 over 2 pi k, where k is an integer not equal to 0. So this is our final solution. So I hope you enjoyed this. Thank you for watching. Make sure to subscribe to the channel if you enjoyed this content.